Thank you.
Okay. Okay. Assalamu alaikum and good morning, everyone. So, welcome to our today's lecture, which is a continuation of time series forecasting. So yesterday we explored the fundamental concept of time series forecasting and examined the ARIMA technique. So today we would like to take a step further and delve into application of support vector machine in univariate time series approach and linear regression as well. As we discussed yesterday, time series forecasting is a vital tool in various fields, which enable us to anticipate future trends and make informed decisions, ranging from stock market predictions, forecasting of sales, estimating future energy demand, etc. So accurate forecasting can have a significant impact on business strategies and decision-making processes. Support vector machines is originally developed for classification tasks. It has gained a popularity in the field of time series forecasting due to its ability to capture complex patterns and non-linear relationships. So because depending on the type of data set you may have, some data, they doesn't have a complex relationship. Some data has a simple linear relationship. Some they have non-linear relationship, which is very complicated. In time series forecasting, SVM offers several advantages, that is support vector machines, which make it a valuable tool. SVM can handle non-linear relationship between variables, unlike linear regression models that assume a linear relationship. If you could remember in your previous machine learning classes, when you are using linear regression, it's just a straight line equation, which is linear. And SVM can allow us to transform data into higher dimensional space. This transformation enables SVM to capture non-linear trends and make accurate prediction, even in the presence of complex patterns within the time series. And one of the best advantage of SVM is that SVM is less sensitive to outliers and noise, which results in more reliable prediction or forecasting. So the second one is linear regression, which is straightforward. The reason why in this class we will discuss about two machine learning algorithms or techniques in time series forecasting. Hello?
So guys, you are saying time of light is what?
Pardon?
You are saying what? Time of light. Time of light is what?
I can't hear you. What are you saying?
Saminu, can you meet him? Okay, Zaharaddeen, you can continue.
Okay. So secondly, linear regression is a straightforward approach that enables linear relationship between historical data points and target variable. The reason in this session we are going to use two machine learning techniques, two machine learning algorithms is that depending on the type of data set you have, although linear regression is a straightforward approach, but in some cases, you may find out that your data set has a linear relationship. So we don't need to use SVM or some advanced time series forecasting algorithms to model your data and make a forecasting. So for this reason, in our today's lecture, we will take a look at these two machine learning algorithms. So linear regression, it assumes that there is a linear trend within the data, meaning that the variable of interest changes at constant rate over a period of time. By fitting line to a data, linear regression aims to find the best fitting lines that minimize the difference between the predicted values and the actual values. So now let us take a look at the first one. is SBM. But in case of regression, as you all know, since this is not your first machine learning class, normally in case of regression problem, we are normally using SBR, which maybe I will discuss. There is a little discussion with the difference between SBM and SBR, although they are all support vector machine based, but in SBM can be used for classification, while SBR support vector regression can be used for regression problems. But they are all categorized or under SBM techniques. So first of all, as usual, we import our necessary libraries. So from sklearn, we import sklearn.sbm, we import SBR. Then in this notebook or in this problem, we are trying to use two evaluation metrics, that is mean squared error and mean absolute error. So now, so this is our data set. This is our, data frame. So as in our previous, I'm now running it again, although I have already run the entire cells of the notebook. So now.
Yeah, I guess you can walk through if you are already.
Okay, I can just walk through.
Yeah,
okay.
Since you have already
okay,
run
but I'm already running it again. So, okay. I'm running again. So this is our data frame. Okay. So as in the same as in the previous example. So we now set our index to be year and month. That is the three columns we have. The three columns we have from our data set. We have 4 columns. We have CO2, carbon dioxide, year and month, year and a month. So we have 4 columns. So, but all these, they are part of our timestamps. So we just consider it as part of index. So we are using univariate time series approach, whereby we are splitting the same column for train and test, because our data set contain only one valuable, I can say only one valuable information. That is carbon dioxide or carbon dioxide. It has only one valuable information that we need to forecast it is or predict it is future value. So Why it is taking long. Again, the sliding window is 3. I just take 3 as sliding window, but if you like, we can change to 5, 7, 8,
Unless,
depending on the.
Zaharaddeen, unless if you want to run it, unless if you kill the notebook,
Okay, let me
restart from the beginning. Yeah. If you
so let me share my. I've already. Yeah, let me share my Jupyter note. Let me share my Jupyter note. It has already. Taking time, I don't know.
No, what I mean, you can close your VS Code and open it again, because it will not take time running the script, so you can run it again if you like.
Okay.
Yeah. So
just share this.
sometimes it does, this stuff. So close the Jupyter notebook and open it again and run it again. It will go and you can share the screen.
Okay. Okay, I'm already closed it. This is giving me headache. I don't know why this is. Let me connect again. Hello?
Yes, Minajinka, we can hear you.
Now, can you hear me now?
Yes, Minajinka.
Let me share my screen again.
Okay, so before
I'm trying
Zaharaddeen.
to share my screen again.
Okay.
I'm trying to share my screen again. Sorry.
Abdurrahman, you can mute yourself, please.
Can you see my screen now?
Yes, it's starting sharing. It will soon.
Okay.
This screen sharing is taking forever. Can you disconnect again and share?
Okay, let me stop. And let me disconnect and connect.
Okay, share again.
Okay, let me share. Let me close some tabs first. I'm sharing again. Can you see my screen now?
Can you see screen? Ni na gari yasa started sharing. Zaharaddeen started sharing. Ban ga ya nuna screen din ba dai still.
Bai nuna ba?
Different.
Exactly.
Ya nuna?
No.
Okay, so maybe let me open my VS Code again. Because
What
I
are
don't
you
know-
sharing in any way?
I'm sharing from my browser, my Jupyter notebook.
Okay, so
Yeah, but is this not his VS Code I'm seeing?
can you see his VS Code?
No, now I'm
Forecasting
open VS Code.
using SVM.
Okay, no, it's
.ipy.
forecasting using, it's my browser. Can you see?
Me, I can see it. I don't know. It's not a browser, rather a VS Code.
No, it is.
Does the
it is
team,
a browser.
hello, after Sami, can anybody see the screen?
We can
No.
see. I can see.
No, we cannot see. Zaharaddeen Karim has been. Now it is coming.
Now it's
Now it's coming.
Okay, Sami da me kake gani?
Well, screen
Okay, now
is I don't know. VS Code
Now
So what
it's
up
obvious.
now? Now you can see my screen.
Yes, we can
Yes,
see
we
now.
can
Yes,
see
it's
the
VS
browser
Code now.
now, Jupyter. Mhm.
now
Yeah,
it's
Jupyter.
visible.
I
Yes.
don't know why my code today is very
So you
slow.
can go on, you can continue, Doctor.
Okay. So let me go back once again. So as I have said earlier, in our today's session, we'll discuss about two machine learning algorithms that we can use for univariate time series forecasting. The first one is SVM, and the second one is linear regression. The reason why we are using these two is that sometimes time series forecasting, like any or many other machine learning problems, sometimes it's trial and error, unless you understand the pattern of your data. So if you don't know the pattern of your data, whether your data has linear relationship or non-linear relationship, so you have to try to use a combination of algorithms, or you can run a separate experiment to see, let me try this to see which one has less error. Since it is a machine learning, unlike advanced time series forecasting algorithms like LSTM and GRU, or a combination of convolutional neural network with LSTM or convolutional neural network 1D, which are very good in time series forecasting, and even transformers as well. But when it comes to machine learning, you have to try maybe to use some ensemble method. Maybe you can use bagging, you can use boosting, and many other techniques. So as we did in our previous experiment, set our index, these three columns, we set them to be our index. I said window size to be 3, which is adjustable. You can change it to 3, 4, 5. But as you increase the number of window size or look back, you are increasing the computation time. And at some point, you may even need a high-speed machines, depending on the type of problem you are trying to solve. So we create two empty lists, X and Y. Let me explain. So these are the variables X and Y, and we have a for loop. So X is a variable. It is X as a variable. It is an empty list that will store the training sample. Each training sample is a sequence of window size consecutive values for the carbon dioxide future from your data set. From our data set, as I have said earlier, we are now trying to divide our data set. That from our data set, we have only one important variable, which is carbon dioxide. So we are trying to split that data set into train and test. So from the same carbon dioxide, we will now take our train set and test set. So the first one is X, and the second variable is Y, which is another empty list that will store the corresponding targets for each training sample. So each target is the carbon dioxide values that follows the sequence of values in the training sample. Then we have a for loop. For I range length of our data frame minus window size. So this for loop iterate from 0 to the length of our data frame, window size minus 1. It generates training samples and targets by slicing carbon dioxide values from the data frame. Then X, at this juncture, we append this. We append our values to X and Y, this two empty list. So X append each iterations of the loop. It appends a training sample to the X list. The training sample is obtained by using df.ilog from I, since it's a slice, I plus window size of carbon dioxide dot values. At this time, we are converting our values to numpy dot values. We are converting carbon dioxide values to numpy so that we can be able to store it in our list. Then Y, in each iteration of the loop, it appends the corresponding target to the Y list. The target is carbon dioxide as a value at an index I plus window size in the data frame. So now we split our data set into train and test. We take X and Y list, but 80% is for training, while the remaining 20% for the test. Then, as I mentioned earlier, we are using SBR, which is also an SVM model. So support vector machine, what are the main difference between support vector machine and support vector regressions models? So these two models are different in their purpose of application. SVM is used for for classification tasks, aiming to find an optimal hyperlens that maximally separate data points of different classes. It can handle linearly and non-linearly separable data set using various kernel functions. As I have said earlier, we can use SVM to capture linear or non-linear relationship between the data in our data set. On the other hand, SBR is used for regression tasks, because if you are using SBR about regression tasks, you are dealing with values which is discrete, while SBR is used for regression, which means that you are using it for values that are continuous. So SBR predicts continuous target variable and can handle linear relationship. While both analyze techniques, their objective and output differ. SBM provides discrete class level, while SBR provides continuous target variable. SBM is used for classification tags to separate data points into different classes, while SBR is used for regression tags to predict a continuous target variable. So both SBM and SBR can be used in the concept of support vectors and optimization technique, but they have different objectives and output formats. In case of SBM is classification, while in case of SBR is in continuous form. The values there in continuous form mostly is meant for prediction and forecasting. So we are normally using SBR for prediction and forecasting or estimation, whatever it. So now we train our model.fit X train, Y train, and our model is SBR. Now we make a forecast. y-frame model.predict x test. So in this regard, I use two evaluation metrics, mean absolute error and mean squared error. So looking at these two evaluation metrics, you can see that mean squared error is 32.49, which is quite high, and mean absolute error is 4.9. We are expecting our model to perform very well so that we can get a very small error. So now let us look at linear regression to see what it can offer in this regard. So as usual, we import our important libraries that we are going to use. This is our data frame. But I encountered some issues. I don't know, while using linear regression. In the previous example, I didn't encounter any problem, but in this case, I encountered some problems of missing values. So at the end of the day, I have to drop some missing values. But initially in my data set, there is no any, but I don't know why. So that is the reason why I put this. So even if there are some rows with missing values, so I can just drop it, because I found it very difficult to run this experiment because it is giving me an error that there are some missing values. So as usual, we now set our index this year, a month, year, a month, year, and a month. We set it to be our index as in the previous example, But in time series, apart from look back or window size, like in the traditional time series, normally they are using lags. That is what is called lags. So now let us take a look at this. I will later explain lags, which is the same as look back, and sometimes some they even use timestamp as well. So now let us take a look at these two codes. So now we are trying to create a lag, a linear regression. Like in SVM, there is no need for that. But sometimes if you are using auto regression or linear regression, sometimes in machine learning, you need to create this lag. So in our sliding window size is, or look back, is 3. So we are now going to use 3 lags. So creating lag feature, the loop for I a range of 1 to 4 feet, iterate over value 1, 2, 3. This loop is used to create lag features, which are previous value of the carbon dioxide column. For each iteration, this line of code create a new column in the data frame with the carbon dioxide like I, lag I, carbon dioxide like I, that is CO2 like I. So e.g. like 1, like 2, like CO2 2, like CO2 3, in this order. So the values in this new column are obtained by shifting values in carbon dioxide column upward by I positions. That is to say, it will move sequentially in ascending order. That is from 1, 2, 3 in that order. So, but why are we splitting our data? So splitting the data, we are now splitting it in this way, as I have mentioned. We are now splitting our X, that is our feature, into 3 lags, lag 1, lag 2, and lag 3. So the next step is after the features we create using lags is to split the data test into training and test set. The line X, lag 1, lag 2, with carbon dioxide like 1, carbon dioxide, CO2 like 2, CO2 like 3. Select the column like 1, like 2, and like 3 from the data frame and assign them to variable X, which represent the input features for the model. The line Y, this line, select carbon dioxide column as the target variable and assign it to the variable Y. The X variable contains the lags CO2 values, while Y contains the corresponding actual values, CO2 values. So in the context of time series forecasting, lags refer to using previous observation of variables to predict its future values. As I have said, this is the main difference between forecasting and prediction. In case of prediction, we are making prediction or estimation on the entire data set. Maybe you have futures and target. So you are now trying to predict features, to predict target based on features. Since features of your data set, they are the independent variables, while the target is dependent variable. So you are now making predictions on the entire, there is no any specification. That is why you don't need any sliding window, lags, or look back. But in case of time series forecasting, you are specifying, make a prediction, take this, maybe your sliding window is 2. Now take this 2, start with this 2, and make prediction then again in that order. But in case of prediction, there is nothing like that. You are just prediction over the entire features and target. So when, again, lag features capture the relationship between variable and its past values, allowing the model to incorporate the temporal dependencies and patterns in the data. So that is why sometimes, that is why always, not sometimes, always you have to, in case of time series data, you have to use your date or timestamp as your index so that the model can easily understand the patterns in your data. And what we are doing in time series forecasting, we are trying to train our model to understand the temporal dependencies of our data. So when creating lag features, you shift the values of the variable backward in time by a certain number of steps. For example, if it is a monthly data, shift the variable by 1 step to create lag of. So by including lag features in a time series forecasting model, you enable the model to use historical values of the variable as input features to predict its future value. The idea is that the past behavior and patterns of the variable can provide valuable information for predicting its future behavior. Just like if you take an example, for people that are into stock market investment, those investors in stock market, they are using a lot of time series forecasting. They are using fundamental analysis. They are using and technological analysis. In fundamental analysis, normally they are using traditional statistical tools, and in technological nowadays, they are using machine learning models to predict the future of stock market and now even the crypto as well, because there are now even the cryptocurrency. You as an investor, if you want to invest into cryptocurrency, you need a good model, or you need a good software, a technological that uses a technology that can give you an insight about the future values of a particular cryptocurrency or stock, or a company, or a stock of a company that you want to invest in. As I've said, I have encountered some missing. I use this code to replace the missing value. Then I split the data into trend set using trend set split. And because it is a time series data, and sometimes in time series data, we don't want to shuffle. Sometimes you may shuffle, but some they advise us that you don't need to always shuffle your data, because sometimes your model may not understand the actual pattern in your data. So this is the reason why I put shuffle is false. So now we train the model using linear regression. We now fit the model. At this juncture, model is equal to linear regression model dot fit X train, Y train. This is our train, which is we train our linear regression model successfully and make a prediction. So now, in this case, I try to evaluate the trend in the two previous experiments. I didn't evaluate, or there's a separate train errors and test errors. But in this, I try to see how, let me see whether we are just measuring the error. So we don't know whether even our models, either they are optimal, overfitting or underfitting. But although from the errors we get in our two previous models, we can conclude that the error is very high. So there may be a possibility of overfitting, but we can't just conclude that because there is. I have this experience. I have run some experiment, time series forecasting experiment, whereby the error is around 30 and 35 for training and testing, but it is optimal. So sometimes, but in this regard, let us see. So we adopted two evaluation metrics, as I have mentioned earlier, mean squared error and mean absolute error. So for the train, to measure the train error, we now use Y train and Y pred for mean squared error, and the same with mean absolute error. So for the test error, we now use Y test and Y pred test. That is why in this, for making prediction, we use for train and for test. So at the end of the day, if you look at our train set matrix, MSE is 1.003, MAE is 0.717. For the test, MSE is 0.803 approximately, and MAE is 0.725 approximately. So looking at this, we can say that the model is it overfitting or underfitting, because it is not optimal. So for me, I can say the model is overfitting. It's overfitting model. But what can you say, Dr. Shamsuddin? And there is one beautiful thing about this. If you look at our two previous examples, you can see that the errors are very high when compared to this one. So this means that linear regression perform very well on this data set, better than SBR and ARIMA model. So sometimes if you are dealing with time series forecasting model, you have to try to run at least 2 or 3. You have to run experiment with at least 2 or 3 machine learning so that you can find which one will work best for you. So Dr. Shamsuddin, what can you say about this model? Are you with me? Hello.
I really answer this. Answer the thing. Can you?
So is there any question? I can't. Are you hearing me? Thank you.
Yes, we can hear you.
So is there any question?
Sir, thank you.
There is a question in the chat, sir.
Okay, let me check. So the question, how can a trend in time series transform into noise, and what are the scenarios where trend is valuable? Also, what is the difference between trend and periodic fluctuation in time series? So mostly trends you can just use maybe through, as well, I know mostly we can find a trend in our data set through explanatory data analysis. We can just plot from our data set, we can just plot some graphs to understand whether there is a trend or not. But you can, from that explanatory data analysis, you can actually find a trend in your data. But for us in time series forecasting, a trend is not good because we always want to use a seasonal data. That is why even if your data has a seasonality, I mean, not seasonal data, I'm sorry, stationary data. So whether your data has some, maybe it is pattern is in cycle form, it has some trends or seasonality. At some point you have to even use some APIs like from stat models, there is a seasonal decompose, whereby you have to decompose that seasonality of your data for you to make a good forecasting. So you can use explanatory data analysis to see the trends in your data, but while making forecasting, while modeling, while trying to build a model is not good. It's valuable for you to see, you can use explanatory data analysis to see the trends in your data set. Also, what is the difference between trends and periodic fluctuation in time series? So trends, periodic fluctuation is a situation whereby you may have, which products I can give you an example that has a periodic fluctuation. Periodic fluctuation is a situation whereby in your data set, at some point, you may have a high, let's take an example of sales. There are some seasonal products. So if you look at a data set that has that for sales of a seasonal products, maybe within a year, or let's say, since we are dealing with historical data, maybe for 3 years, 4 years. So you can see that periodic fluctuation, because if, for instance, during the hammer times, the products are required, there is high demand for that product. So you can see that the trend will be high, and at some point it will drop. It will be fluctuating from high to low. I hope you get my point. But for the trend, you are just trying to look at the patterns in your data, how it moves. You understand? So through that trend, you may find periodic fluctuation in your time series data. I hope I explained very well. Pardon me if I'm wrong. I'm still a student trying to learn this. So is time series only applicable to numerical continuous value, or it can be used to forecast using EG? No. It is, you can only use time series forecasting model because it's regression problem. You can only use it when you have a continuous values. That is why right from the basic machine learning, under supervised machine learning, you are told that you can use classification. I mean, you can use either classification or regression. So in classification, the data must be in a discrete form. It must be in a discrete form, mostly, while in case of regression, your data set will be. But at some advanced level, you can use, but whatever the case may be, you have to combine. you have to use continuous values in time series. Is there technique available to assist in selecting optimal window slide number? Mostly you can decide because it depends on your problem. Mostly sliding window, you can write, but mostly we then in time series forecasting because we know what you want to do. Mostly you are just specifying, but you can use some method, you can create some methods that can try to find some sliding size.
So,
Is it necessary to use year, months, and column from the column I see now? So this is the data set. Is it necessary we use year, months, and column? It depends on the data set. Some data set you contain only time and date. Maybe it has date column, it has time column. It may not necessarily contain. Some they have date and time, depending on the type of data set. So when we talk about what is the difference between sliding window and moving average? So a moving average is a regression. If you go back to maybe we are just using it is a topic on its own, to be honest, because auto regression, integrated moving average, there were two techniques combined in case of ARIMA, because it is just an introduction. It is just an introduction within it, because when we talk about there is auto regression on its own, you can use it in traditional statistics, and there is moving average. So when they are combined, auto regression, integrated moving average, this is how ARIMA model was formed. So it is a topic on its own. We may spend more than an hour trying to explain moving average, but I think if you can take a time series course on Kaggle, all this they are explained there. There is time series forecasting course on Kaggle that you can cover, that you can finish within 2 weeks, within 2 to 3 weeks, or even in a week. If you have an ample time, within a week you can cover that course. So time series, all this they are there, because in moving average there are a lot of calculations. So is there any other question? So apart from that, we have covered how we can use SVM and linear regression. But if you look at these two algorithms that we use, there is no any hyperparameter optimization. Also, sorry, I have been running this for more than an hour, trying to show you how we can use grid search CD to optimize our SVM, this model, these algorithms that we have just used. If you look at the errors are 32, mean squared error is 32.497 approximately, and mean absolute error is 4.894. So I am trying to see how can we reduce this error by trying to find the optimal hyperparameters. So I've been running this for a while, because me too, as a student, I'm struggling with some other things, because I am under intense pressure to submit a report. So, and it has a deadline. So that is why, pardon me. So maybe after I have finished running this, I will attach all the notebooks and upload it on Iowa Data's Science repository, inshallah. So that if you need any more explanation, maybe I'm already on Slack, and I will try to respond to questions through Telegram.
Okay, thank you very much. That's wonderful session. I share the course for Kaggle, for time series in Kaggle.
Yeah,
so vital. if you are interested to explore more about time series, you can spend like 5 hours, I can think, this Kaggle course is like 5 hours. You can learn more, I think, from that. Yeah. So thank you very much, Zaharaddeen. Now
Thank
it's
you
time
very
for
much,
questions. If you have any question, you can unmute and ask your question now.
Assalamu alaikum.
Wa alaikum salam.
So regarding the data frame you used, can we ignore the year and month column? Because during in your month column, your year and month column, I don't understand what I don't get. Is it the .71, 38, like that .38? Does it represent the month?
Let me go back. Look at it in our data set. Look at the way we have. This one is just a year. This is just the data set I downloaded. You understand? It depends on the way, no matter how it is. If you look at it, it's maybe year and time, whatever. Look at it, year and month. This is how the data set it is. The main aim for using this data set is to show you how you can use time series data. Look at it here, because it has no, this year, months, year and months, year, month, they have no influence on your data. All what we are trying, you are using it as an index. Look at it, initially this is our index in sequential order 0, 1, 2, 3, 4. You get it? Just in sequential order. So for your model to understand the temporal dependencies on your data, because it is time series forecasting data, you are now setting your index into this. Let me show you. We are now setting, maybe you can see, let me run this again. So look at it now. Let me remove this. So if you look at the way it is, now we are setting this CO2, all this year, month, and they have no influence. If you look at it, we have only one. Look at it, name is CO2. This is the only column now you have. The remaining year and month, they have no influence on your data. You understand? They have no influence on your data set because you are only using, if you look at it throughout our experiment, we are using carbon dioxide column. We don't use either date, time, you understand? But we are using it as an index so that our model can understand the temporal dependencies, because it's just like space and time. You understand? Most of the time series data is more of time, because it may consist date, time, you hope you get it. So that is why mostly we are using time series data. We are using time as an index. So is there any other question? Okay, multivariate time series forecasting. So multivariate time series forecasting is an advanced forecasting model. In case of univariate time series forecasting, you can use only one variable, like what we are now doing. But in case of multivariate time series forecasting, so in case of multivariate time series forecasting, you can use either way. You can use two or more variables, that is, or features, to predict two or more features. If I like, I can use multivariate time series forecasting, assuming that I have my data set, stock market data set, it has maybe closing, opening price, closing price, and volume. So if I like, I can use multivariate time series forecasting. Based on the previous, like what we did now, we use only one column. So with these three columns, I can use this data as a previous values, as I can use it as previous values or historical data to train and test my model, in the sense that I have data, I can take train set from volume, train set from opening price, and another train set from closing price. And from this, I can also take the remaining part, I can take train set and test set, and I can use to make a prediction, which is multivariate. And at some point, you can also use multivariate time series forecasting to try to find a complex correlationship between two variables. More especially if the relationship is very complex, you can apply advanced time series forecasting models like LSTM or GRU, long short-term memory, or gated recurrent unit. That is, these two, they are the most famous one. Or nowadays there are also transformers and many other hybrid, or you can use some hybrid combination whereby you can incorporate this model with some time series forecasting model with some other models, depending on the type of problem you have. So you have been mentioned temporal dependencies. What we are talking about temporal is just like a terminology of time dependency. It's just time dependencies. It is used in time series temporal, but it's just time. Temporal dependencies means time dependencies. So is there any other question?
Assalamu alaikum.
Wa alaikum salam.
So regarding the data frame I told you earlier, can't I just ignore the year and month column and just use it to, since the year and month column isn't that much comprehensive?
Pardon?
Since that year and month column isn't that comprehensive, can't I use the year column and month column as my index?
If you like, you can just choose one. If you like, you can just choose one. If you like, look at it. You can just use, because this is a combination, year and month as an index, and you can drop these two columns. You can drop this, but year and month. But if you look at it, if you can just, whether you use it or not, they are just part of the data set. You don't need, because they have no influence. The only advantage it has on your data set is for your model to understand the time dependencies in your data. That is the main advantage. That is why you can just use sequential order as an index from one to the last data points, or last row of your data. So if you are using date time as an index, so now your model can easily understand the time dependency of your data. So it can easily understand the pattern of your data. So that is all about it. Is there any other question? Okay, sorry. So is there any other question? Dr. Shamsu?
Hello. Hello. Thank you, Doctor.
Seems like there is no.
Yeah. I think you have exhausted all the questions, and thank you for the nice presentation. And if there is no question, I think we can call it a day. And I mean, the video and other related materials will be shared in due course. Thank you, fellas, for listening. I hope you had a very wonderful time. And, we hope others will pick this area.
Thank you for having me. I'm very much sorry for the technical issues today, because we didn't start.
No
Technical issues, which is unavoidable. Thank
That's
you once
something
again.
beyond your
So
control.
I'm just
So
also a
thank you.
student. If you have any problem, you can ask. If I'm wrong, please pardon. I'm also a student. I'm still learning.
Thank you so much.
Okay, so thank you very much for
Yeah, so in the absence of any question, I think we will meet on Tuesday, inshallah. Thank you so much. Bye.
Okay, so thank you.